Okay guys, so some new integration and derivative formulas. These are on your green sheets. This will finish up with our last new formulas. For this one, we have the derivative of a to the u. This is where we have a base that's not e. Okay, so a base of 2, a base of 3, a base of 4, a base of 5. This is our formula. Natural log of a times a to the u times the derivative of u. So this would be something if we had, say, the derivative of 5 to the x. Well, that derivative, in this case, a is 5, u is x. So this would be the natural log of 5 times 5 to the x, and then times the derivative of our x, which would just be 1. So that's the derivative of 5 to the x. Okay? If we have to find the derivative of log base a of u, this is going to be 1 over the natural log of a times 1 over u times du dx. So this would be as if we have the derivative of, say, log base 4 of x. That derivative would be 1 over, here's our a, natural log of 4 times, this is u, 1 over x, times, and then the derivative of x is just going to be 1, so this would just be 1 over x natural log of 4. Okay, so these look complicated, but it's just because you haven't really practiced doing them. Okay, it's just a formula, you just need to be able to apply the formula. If we're integrating a problem where we have a to the u, this integral is going to be 1 over the natural log of a times a to the u plus c. So this would be as if we have the integral of, say, 6 to the x dx. So that integral is going to be what? 1 over the natural log of, what's a? 6 times what? 6 to the x plus c. And so that would be 6 to the x over natural log 6 plus c. Okay, so that's just a real simple way to use those formulas. They're not difficult. It's just a matter of looking at the formulas and then applying them. All right, let's look at number 1 now. We're taking the derivative. With the derivative, we have to be thinking about the chain rule. With integration, we use a u substitution, but with derivatives, we use the chain rule. So for this problem, in this case, a is 3, u is negative x. So to find this derivative then, the derivative of a to the u is the natural log of 3 times 3 to the u, which is negative x, times, we have to use the chain rule, what's the derivative of negative x? Negative 1. So my final answer would be negative the natural log of 3 over 3 to the x. Do you see why I put the 3 to the x on the bottom? To make it have a positive exponent. Questions on it? All right, let's look at the next one. This would be our first value. This would be our second. The reason I know that these are two terms is because this has a u and this has a u. So we have two factors. This is getting multiplied by that. So we're going to have to use our product rule. F prime g plus f g prime. Well, f prime is just the derivative of this. I really just did it over here, but I'll do it again. So it's going to be the natural log of 3 times 3 to the negative u times negative 1. That's my f prime. Then times g, so times sine of pi u, plus f is 3 to the negative u, times, and then g prime, derivative of sine u is going to be cosine pi u times, and then the derivative of pi u is just pi. And now we're just going to simplify this. So here's my first term. So this is going to be negative the natural log of 3 sine of pi u over 3 to the u. Here's my second term right here. This is going to be plus pi cosine of pi u over 3 to the u. So now we have a common denominator, so I can just put these together. So it's the negative the natural log of 3 sine pi u plus pi cosine pi u all over 3 to the u. So these are going to be longer answers, but they're really not any more difficult. It's just a matter of following the formula and using everything that we've learned with the product rule, chain rule, and all of that. All right, let's go on to number 3. Number 3 is a log. So we're going to look up at our log basic formula. It's log base A of u. You might want to write down, what is A? Teresa, what's in the A spot? And then u, what's u, Brandon? U is? So we're looking at our formula now. We've identified A and u, so now we're just going to use the formula. So it's going to be f prime is equal to 1 over the natural log of A, which is 6, times 1 over u, 1 over 3x, times the derivative of our 3x. What's the derivative of 3x? 3. So these cancel, and so our derivative is going to be 1 over x, natural log 6. Questions there? All right, number 4. If we have logs, we always want to expand them before we start trying to find derivatives. So I might want to write this as, this is x squared plus 1 to the 1/2. What can I do with that 1/2 then? Right, we want to put that in the front. The reason that we want to do that is because we would have to use the chain rule on this when I go to take the derivative of that, and it's pretty tough to do. It'd be 1/2 u to the negative 1/2 times the derivative of the inside. Not fun. But if I bring this 1/2 out in front, the derivative's pretty easy. I bring down the 1/2. I look up here, my a is 3, my u is x squared plus 1. I look up the formula, here it is. So it's going to be 1 over natural log of 3 times 1 over u times the derivative of u. What's the derivative of u? 2x. And now I'm going to see if there's anything I can simplify, and there is, because I have 2x over 2, I can cancel those. And so now I have x over natural log 3, x squared plus 1. Questions? All right, so now let's switch gears. We're going to be integrating now. So let's look back at our integration formula. The integral of a to the u is 1 over natural log a times a to the u plus c. Okay. And guys, remember, like this year, I haven't made you memorize any of these. You get to use your green sheet, but that's probably not going to be the case next year in calculus when you take it for real in college. If I were you, I would hang on to that green sheet because it's got all the integration formulas and derivative formulas, and it's going to be a nice reference for you. Because in most calculus books, all of those are kind of scattered throughout the entire book, and then you need a formula and you're like flipping to page, 123 to find the formula for something. But if you just keep that sheet, it'll be helpful. All right, so let's try these two now. So we're trying to find this integral, and it's a definite integral. So I'm going to look at my formula right here. A in our case is going to be 3. U in our case is going to be x. And then I just review the formula. So it's 1 over the natural log of A times A to the U, so 3 to the x. And do I put plus C if I'm going to use a definite? No. Definite means that we're trying to find the area under the curve. So go ahead and get out your calculator. I want to remind you of how you can check this. This answer is going to be 3 to the x over natural log of 3. That's what we came up with. Oops, but we have to plug in our numbers. So we have to plug in 4 and 0. We're not going to check yet. So if I plug in 4, what's 3 to the 4th? 3 times 3 times 3 times 3? 81. So it's 81 over the natural log of 3 minus, now plug in 0. What's 3 to the 0? 1 over natural log of 3. So 81 minus 1 is just 80 over the natural log of 3. So that's going to be our exact answer. That's what we want to have for the exact. But remember, you can always go to your calculator, go to y equals, type in 3 to the x, do a zoom 6. Here's the way the function looks. I'm going to go second trace, calculate the integral from 0 to 4, and it tells me that the answer is 72.82. Well, I'm going to check my answer. 80 divided by the natural log of 3 is 72.82. So therefore I know that this answer is correct. We would always like to give the exact answer. Right here is the exact answer. This is not exact. Even if you wrote this whole thing, it's still not exact, because the calculator is just rounding to whatever that last digit is. This is irrational. It goes on forever. All right, number 6. This one's pretty tough. Usually when we have a problem like this, we let u equal the exponent. But if you think ahead, letting u equal the exponent is not going to get rid of anything else in the problem. If we're integrating, there's no quotient rule. There's no product rule. So when we're integrating, we have to get rid of all quotients and products. Can anybody think of what a good thing might be to let u equal? Nope, we already said it can't be 3x. It's not going to get it done. The reason 3x isn't going to get it done is because I would still have a quotient. Just 5 to the 3x, that's better, but I still couldn't get rid of the denominator. Chad?
1 plus 5.
Yeah. We have to do u equals 1 plus 5 to the 3x. You need to let u equal the entire denominator. Here's why. If I take this derivative, the derivative of 1 is 0. The derivative of a to the u, let's go back up here. The derivative of a to the u is the natural log of a times a to the u times du dx. And the derivative of the u is 3x, which is 3. Now, look at what we've got so far. This right here, what's that going to be? That's u, isn't it? I want to get rid of this. What I want to get rid of is this part and this part. So I have these extra. So how do I get rid of those? Hold on. How do we get rid of those? Divide. So I would have to say then that 5 to the 3x dx right there is going to be equal to 1 over 3 natural log of 5 du. Okay? See what I'm doing? I'm dividing both sides by 3 natural log of 5. So we're going to have 1 over 3 natural log of 5 integral of, what does our problem now become, guys? Just 1 over u. Look at your green sheet if you don't remember the integral of 1 over u. Does anybody remember the integral of 1 over u? Natural log of u, right. So then we're going to have 1 over 3 natural log of 5, natural log of u plus c, but we need to plug in that. Do you know how I went from here to here? Remember how if we have this as a coefficient, it can become an exponent? If it's a constant, remember that, how they get moved back and forth? So I just made it 5 to the third, which is 125. You don't have to, you can leave it like that. All I did here was just replace my u with what u was equal to. Okay? So on this kind of problem, guys, when you're integrating, if this denominator is close to the numerator, that's what you're going to want to let u equal, instead of letting it equal the exponent. Most of the time, it's the exponent, but not on something like that. Okay, any questions over any of that? All right, so I cut down the homework significantly from what's on the assignment sheet. You only have 8 problems to do, 4 with derivatives, 4 with integrals. So I want you to go ahead and get started. You still have 15 minutes. Get the first couple done, 41 and 45 at least.